Welcome to Dataless U. I'm Paul, coming to you from Brooklyn. Today we are going to take a look at the mean value theorem for integrals. We are going to do question number 5 from page 469 in old James Stewarts' single variable calculus textbook. So open up and we'll take a look. I've already got the question and the formula up on the big board. So briefly, the mean value theorem is used to find the average or mean value of a curve over a given closed and continuous interval. So let's say the weather is changing all day. Well, at some point during the day, we will hit the temperature, which will result in the average temperature come end of day. And temperature changes constantly. It fluctuates minutely every moment. And so the integral or the mean value theorem for integrals is an excellent way to compute what that average is. So let's take a look at the theorem itself first. F of c, so the function evaluated at some value c, is equal to the average that we've just discussed, which is equal to 1 over b minus a times the integral from a to b of f of x dx. The problem we're concerned with is f of x equals x minus 3 squared over the interval from 2 to 5. I have that simple parabola graphed here on the right hand side of the big board. Notice it's just a parabola shifted over to the right 3 units, and we are only concerned with the region from 2 to 5. I've shaded in the area under the region, and you'll see why when we get to part C of this question. But let us begin with part A. Part A says find the average value of f on the given interval. In order to do so, we merely have to plug our particular numbers into the formula. So f of average for us is equal to 1 over 5 minus 2 times the integral from 2 to 5 of our function, which is just x minus 3 squared dx. Don't forget your infinitesimal. So that's equal to 1/3 times, well, the integral of x minus 3 squared is, of course, x minus 3 to the 1 higher power, that's to the 3rd, over that number 3. And we're going to evaluate this from 2 to 5. Okay? So that equals, just keep going here. We'll put our equal sign here. 1/3 times, well, when we plug a 5 in there, 5 minus 3 is 2. 2 cubed is 8. So that's 8 over 3. Minus, when we plug a 2 in there, we get 2 minus 3, which is negative 1 to the 3rd, which is still negative 1. So we're going to have minus a negative 1/3, so we'll just go ahead and say plus 1/3. Beautiful. 1/3 times 8/3 plus 1/3. Well, 8/3 plus 1/3 is 9/3, which is 3. 1/3 times 3 equals 1. We'll go ahead and make a fancy 1 since it's our answer to part A. Part B says find C such that f average equals f of C. Well, our f average we just solved for. That's 1. We just solved for that in part A. So we take that and set that equal to the original function itself. So, not so bad, right? X minus 3 squared. So we're going to square both sides. We'll just get 1 equals x minus 3. And we will add that 3 over. So we get x equals 4. But notice, square root of 1 could also be negative 1. I'll put a little dotted line and show this other solution. Could also have negative 1 equals x minus 3. And then when we add the 3 over, we actually get x equals 2. And lo and behold, look, at 2, as we've already graphed, we're at 1. And now, what our formula told us is, well, at x equals 4, we're also at 1. Okay. And so you can see, in other words, what this means. Let's get a new and interesting color here. Let's go with some blue. What that means is right here, this dotted line essentially is the average value of this function, and of course only over that interval. I show the whole dotted line, but it's going to be the average value of the function over this given interval. So let's look at part C, in many ways the most interesting part. It says sketch the graph of f, which we've done, and a rectangle whose area is the same as the area under the graph of f. Okay, so essentially what this tells us is that what the mean value theorem means geometrically speaking is that we can draw a rectangle over this curve whose base is our interval from 2 to 5. So I'm just trying to sketch a little line right here from 2 to 5. And whose height is up to that point C, or really this is, of course, is f of C, which is the 1. That's our height, right? Equals 1. And the area of this rectangle, right, and I'll just sort of shade it here in blue, is equivalent to the area under the curve from 2 to 5. So in other words, it's telling us that the area under this curve from 2 to 5 is equivalent to the area of a rectangle with a base of 3, that's from 2 to 5, and a height of 1, which we discovered using the mean value theorem. In other words, the area under this curve is 3. There you have it. That is the mean value theorem. Thank you for joining me, and I will see you in the future.